Hey everyone, and welcome back to the channel. Today, we're tackling LeetCode problem number 34, find first and last position of element in sorted array. This is a medium-level problem, often showing up in technical interviews, so mastering this will be a huge boost to your coding skills. The problem statement is straightforward. Given a sorted array of integers, nums, and a target integer, target, find the starting and ending positions of the target value in the array. If the target is not found, return -1, -1. Seems simple enough, right? But there are some subtle challenges we'll explore. We'll be focusing on a dynamic programming approach, although other methods exist. Let's dive in and see how we can solve this efficiently. Understanding with examples. Let's solidify our understanding with a few examples. Imagine we have the array 5, 7, 7, 8, 8, 10, and our target is 8. The expected output is 3, 4, because 8 first appears at index 3 and last appears at index 4. Now let's consider another example. 5, 7, 7, 8, 8, 10, with a target of 6. In this case, the target isn't present, so we'd return -1, -1. Finally, let's try one more. 2, 2, with a target of 2. The answer would be 0, 1. These examples highlight the need for a robust solution that handles various scenarios, including the case where the target is not found or when the target is present multiple times. Understanding these edge cases is crucial for a complete solution. Brute force approach. A simple, but inefficient, approach would be to iterate through the array and check each element. If we find the target, we record its index. We'd continue iterating to find the last occurrence. This brute force method has a time complexity of O of n, because we might have to traverse the entire array. While it works, it's not ideal, especially for larger input arrays. The space complexity is O of 1, as we're not using any extra space proportional to the input size. It's important to understand this approach to appreciate the efficiency of the optimal solution we'll explore next. We need a better approach that leverages the sorted nature of our input. Optimal solution. Given that our array is sorted, we can employ a more efficient approach using binary search. We'll perform two binary searches, one to find the first occurrence of the target and another to find the last occurrence. In the first binary search, we'll adjust our search space to find the leftmost occurrence of the target. We'll keep moving our right pointer to pinpoint the first instance. Similarly, in the second binary search, we'll adjust the search space to find the rightmost occurrence, keeping track of our left pointer. This method significantly improves efficiency, exploiting the sorted nature of the array to our advantage. The beauty of this is that we can find the first and last occurrences in logarithmic time, making it far superior to the brute force method. Code implementation. Let's see the code in Python. We'll define a function, find first and last, that takes the nums array and the target as input. We'll use two helper functions, find first and find last, which implement binary search tailored to find the first and last positions respectively. Inside each helper function, the binary search logic focuses on adjusting the left or right pointer accordingly until the target is found or the search space is exhausted. These helper functions then get called in the main function. It's all about carefully controlling where we move our search pointers to ensure we find the exact first and last indices. Let's go through the code line by line and see how it works. We will also handle the edge cases like empty array and the target not being present. Time and space complexity. Now that we've implemented our solution, let's analyze its efficiency. Because we're using binary search, the time complexity for both finding the first and last occurrences is O of log n. Since we performed two binary searches, the overall time complexity remains O of log n. This is a significant improvement over the O of n time complexity of the brute force approach. The space complexity remains O of 1 because we're not using any extra space that scales with the input size. This optimized solution excels in performance, particularly with larger datasets. Engagement break. Before we wrap up, I hope you found this explanation helpful. If you did, please give the video a thumbs up. And if you haven't already, subscribe to the channel for more LeetCode problem walkthroughs and algorithm tutorials. Don't forget to leave a comment below. Let me know if you have questions, suggestions for future videos, or if you solved this problem using a different approach. Your feedback is invaluable. Conclusion. So, we've successfully tackled LeetCode problem 34, mastering the art of finding the first and last positions of a target element in a sorted array. We started with a naive brute force approach and then implemented a far more